Data and math. Data or equations. In this video, we'll explore the question of notation, specifically whether or not using data to represent an equation is more desirable in certain scenarios. A little while back, I was working on a problem that required me to compute the Polygon numbers. I was struggling to remember the equation to generate them. So I thought, what if I take 0, 1, and the Polygon number sequence that I want to generate, and use those as the data points for a quadratic function? Will that give me the same quadratic function as that Polygon number? I was excited to discover that yes, these 3 data points will give you a function that generates all of the subsequent data points for that Polygon number. Furthermore, there's a very simple relationship between the data points for each of these Polygon numbers. You simply increment the furthest most column. With this in mind, we can represent all Polygon numbers with the following. The data notation 0, 1, 3, 0, 1, 4. This defines a set of quadratic functions that are linearly related. I think this example illustrates the advantage that data notation might have in certain circumstances. It certainly is more memorable for me, and I don't think I'll ever forget how to generate the equations that give me the Polygon numbers. In the future, when I encounter an equation or formula that's a good candidate to be expressed primarily in data notation, I'll make a video outlining my reasons for believing so. Before I end this video, I went over to math.d8data.io using the Fractal Triangle app. One of the things that became apparent to me immediately when viewing the Polygon numbers from the data notation was that we could simply iterate them backwards, and that there were negative Polygon numbers. Here, I've graphed the sequence starting with -3. The same linear relationship holds, and I've extended it 9 iterations. We can see at the middle of this graph are the natural numbers, and we have the triangular numbers, the square numbers, but there is a inverse for each of these. Interesting. Web Demo and JavaScript API available at math.d8data.io.